All right, we are going to talk about some graphing basics, and we are going to focus on just two types of graph right now, bar graphs and line graphs. And I'm sure you know there are plenty other types out there, but these are the two that we are going to come across most often in science. So let's take a little bit of time here to review. Uh, okay, so a bar graph. When do you use a bar graph? Well, when you have data that can be separated into categories, you want a bar graph. So on the x-axis, here's the x, here's the y, you're going to have categories. In this case, it's months. And on the y-axis, you're going to have usually counts of something. Like here, we're counting students, or percentages are pretty common as well. So the way you know that you want to choose a bar graph for data like this is that there is no continuity between the categories here. There's no data that exists in here between the January and February bars, right? There is a number of students who have birthdays in January, and there is a number of students who have birthdays in February. There's no continuous, there's no data in the spaces here. Whereas, going to the next slide with line graphs. Line graphs you choose to use when your data shows a trend and there is continuity between the data points. So here we've got Anna's progress along the Appalachian Trail on August 23rd. So on the x-axis, we have time, and on the y-axis, distance hiked or walked. So we have a data point here, for example, at 5 hours, she has traveled, looks like 3 kilometers. And the next data point here is at 8 hours, she's still only traveled 3 kilometers. So it looks like she was standing still here. But there's data between these 2 points, right? It's continuous, it shows a trend. Let's see, what's next here? Okay, getting the axes right. Let me smooth my little face here. So this is, we're going to focus on line graphs a little bit now, and making sure when you're constructing a line graph, you need to put the data on the axes correctly. And all right, we're going to try this again. The convention is that the x-axis is the independent variable, and the y-axis is the dependent variable. So I like memory tricks, and dry mix is a mnemonic that you can use. So when you spell out dry mix, dry, D for dependent variable, or the responding variable, that goes on the y-axis. So dry is dependent, whereas on the x-axis, X for mix, is what you have manipulated or changed in your experiment. And what I often think of is independent is what I have changed in an experiment. So that is the overview of getting the axes correct. Now we go forward. Okay. Okay, so let's practice here. We've got a situation. So a farmer wants to know if there's a relationship between the amount of fertilizer, kilograms, that she uses and how tall her corn grows in centimeters. So we, in order to put these two variables, we've got the fertilizer in kilograms and the height of the corn in centimeters. We need to know which is the thing that she changed, the independent variable, and what was the responding variable, or the dependent. So she changed the amount of fertilizer, so that goes on the x. So fertilizer, and always, 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 you need units, because otherwise we have no idea what we're talking about. So actually, I should probably say amount of fertilizer. That's the x-axis label. And the y would be height of corn in centimeters. Okay. All right, titles. So we have the same situation here, the farmer and the relationship between fertilizer and corn height. So here are my tips for writing titles. So what you want to remember is that the title always needs to refer to both variables, the independent and the dependent. A simple way to do that is just to sort of say this, graph is X or Y versus X. That works. But sometimes it's not enough because your goal is to, why can't I move my face out of the way here? Your goal is to make sure that someone who picks up your graph knows, if you did an experiment, what it was. You need a lot of information in a graph title. So what I always say is that graph titles are often awkwardly long. So lots of words. And example here, so a simple title for this graph would be corn height versus amount of fertilizer. That does the job, it says what's on the graph, but I might argue that it's a little bit too short, too concise. So here's another option. How does the amount of fertilizer affect the corn height? You can see it's in the form of a question. But this title actually gives us more information because it tells us that what the question we were trying to answer was. So we were changing the amount of fertilizer to see how it changed the height of the corn. Okay. The last thing we need to go over is how do you add category divisions onto a graph. So here we have a set of data, looks like length of string versus frequency in hertz. So I think this has to do with what size waves or you get using different lengths of string. So that's not important. So what was changed here is the length of the string. So that is the x-axis label, the independent variable, and the dependent was the frequency in hertz that resulted. All right, so for the x-axis, we've got string lengths from 10 centimeters all the way up to 150. And what you should do is sort of look at how much space you have. I've got 1, 2, 3, 4, 5, 6, 7, 8 divisions on this grid. And I'm gonna, let's, sometimes this is a little bit trial and error, but 0 to 150, what happens if we label each by 20? 40, 60, 80, 100, 20, 40, 160. So this is going to fit all of the string length data, right? My 10 will fit, and the biggest number, 150, will also fit, which is great. So, and I've used as much of the space here as I can. So you always want to spread out the data. And absolutely must have even intervals. So let's say you started labeling your axes and you realized you were running out of room. So all of a sudden you changed from 20 to 40 to fit it in. That is not okay. That is not okay. So if that happens, you have to erase and redo it, choose a different interval. So that brings me to why we use pencils to do graphs, because erasing is inevitable. It's going to happen. Okay, y-axis frequency. So I've got some less even numbers here. They're sort of jumping around, some of them by halves, some of them by whole numbers. And it looks like we go from 11 up to 25. And I've got 1, 2, 3, 4, 5, 6 divisions on my grid. So let's do 5. 5, 10, 15, 20, 25, and 30. So this will fit all of my data, and it uses as much of the space as possible, and the intervals are even. All right, looks good.